Welcome, everyone. I am Michael Gibbs, and we are back with our AWS Advanced Networking course, our AWS Advanced Networking Bootcamp. But tonight, we're going to have a lot of fun. Tonight, I am here with my good friend, Imran Shakur. Imran is one of those people that's been working in networking for so long and has so much experience, and he's a good friend. I had to bring him to share his experience to help all of you. So, for those of you that don't know me, my name is Michael Gibbs. I'm the founder and CEO of Go Cloud Architects, and I've been in tech for 25 years, and I've been in networking for 25 years. In fact, my original CCIE number is 7417. Now, Imram's really been in tech because Imram has 2 CCIEs. He's actually in the process of finishing a third one just to prove to his son that anybody can do it. He's got every certification known to man. He's worked for Cisco, he's worked for Juniper, and he's got decades worth of networking experience, and he's a true expert. Because I live purely in the cloud architecture world, the network architect world. Imran is both equally at home in the network engineering world or the network architecture world or the cloud engineering or architecture world. And Imran does a lot of work with us, and he's got some special networking things he does with us because Imran is about the best there is. So super excited to be here with Imran tonight. Now, tonight we're going to do some cloud engineering kind of things. And for the cloud architects like me, just because we don't configure, just because we are not hands-on, it doesn't mean we shouldn't know how to. So Imram's going to help us with the AWS VPC. We'll probably do some AWS VPC Peering. We're going to look at some VPC endpoints. We'll talk about what is an endpoint. We'll do a tutorial on the VPC. We'll go over some AWS networking services. We'll probably play with some AWS network ACLs. We'll probably play with some AWS security groups. Who knows? Maybe we'll play with Cloudhub. Maybe we'll do some VPC peering. Maybe we'll play with AWS Privatelink. The point is, we're going to have fun. We're going to get hands-on technical, and we're going to start from scratch. Imran is going to help us build. We'll start with the VPC or wherever he wants to start, and he's going to walk us through. So it's going to be a hands-on experience. And Chris and I are going to be here to do anything we can to support Imran. So first, let's give a round of applause for Imran. Imran is as good as we'll ever be lucky enough to find in our entire life. I've been in this field forever, and Imran is as good as it gets. I've never met anybody better. That's how much trust and faith I have in Imran. He's that solid. So he's here to help you. And I'm really excited and grateful to have him here. And by the way, you may see some cloud network architect programs coming from us at some point in the future. And if it does, chances are it'll be a collaboration between Imran and I, because we've been the networking people. We're both from Cisco. He's even spent time at Juniper as well. So we're excited to get started. So Imran, if you want to introduce yourself for a minute, tell people what you've done for a couple of years, and let's have some fun. Let's start configuring things.
Hey, thank you, Mike, for the nice intro. You already introduced me enough. So guys, I've been with the industry for a decade, for more than 25 years with Cisco, dual CCIE, and working with a large enterprise network migration, design, implementation, end-to-end, and now in the cloud space for a while. So I'm here to help Mike, whatever the audience is looking for, some kind of a VPC overview. What is the key thing with the design? How you design the VPC? How do you design the subnets? What is the default VPC is? How do you define a new custom VPC? I think the concept will drive the concept is, so everybody will understand, and then walk through the AWS console, whatever we can show during this time, and we'll go from there. Thank you, Mike.
So Imran, if you want to take it away, if you want to maybe go to AWS, go to the management console, let's start from scratch, build it up. Who knows, if we can create 2 VPCs, we'll do some VPC peering, but let's just get you to set up.
Let's start some conceptual thing first, Mike, and then we can start the AWS console. You can see the screen on the AWS console. So
absolutely.
I'll just start some of the basic design ideas, like what is AWS VPC is. Of course, we already taught this. VPC is a logical construct portion in the AWS, and there are is based on the region. It's a regional property, and basically there are a number of subnets you can create, and within the availability zone, the availability zone is just like a data center. So every different region have a different multiple availability zone for redundancy, and we can go and take a look. So subnets will be created and within the AZs, and their EC2 instance will be created. And of course, this is a default route tables we are seeing. So there are some internet gateway we need to create if we have a private public subnet, and there is a router, and in between you can see that's implicit there for routing between the public and private subnet. So we'll go through these things, and of course there are EC2 instance from public subnet and the private subnet. So I'll walk through these things step by step.
It's great, Imran.
Yeah, you're seeing my screen?
Absolutely.
Yeah. So I logged in. You can see I logged in as my account, and I'm logged in as Oregon region. So there are multiple regions available. So the key thing is, if you see the VPC, I'm already on the VPC dashboard. If you see on the VPC, if you click on it, so this is the default VPC. Whenever you create your account, it's coming up. So whenever you create your account, the VPC, the default VPC will be created. The default VPC will be created, and the subnet will be created by default. If you can see, this is the CIDR. That's the default. We can't change it. We can't delete it.
So Imran, let's explain that CIDR range for everyone. This is the block of IP addresses that your organization would use. So whenever you create your subnets, you're going to create them out of that block.
Correct. But this is for the default. You can you can customize it based on your requirement. We will do in a couple of going slides. Definitely, yes. So I'm just walking through the key thing is on the VPC dashboard. So if you see this is, I'm not sure it's like yeah. If you see the subnets here, yeah, you can see the subnets are already assigned. That subnet means this is like a availability zone. So at the time when I created this on Oregon, we have 4 availability zone. So you can put your EC2 instance on different availability zone. Different availability zone means different data center. If you take a look, these are the hosts available on IPv4 subnets, and if you see, they are on the different availability zone 2C, 2A, 2B, and 2C. And you can take a look the availability zone ID as well. But they are, of course, US West, and they all have the route table, the default routing table, and there's a default network ACL. And if further you can see, they all have auto-assigned public IPv4 IP address. It means whenever you assign whenever you have any EC2 instance, these addresses are publicly, and your EC2 instance will get a public IP address. But when you create the private IP addressing, is by default is not on. So it's a matter of when you're defining the public and private. So if you see the IPv6 auto assignment is off, we need to turn it on if we need it. So that the next thing is, this is all, I'm just driving to the default VPC and the default subnets. We have not create any VPC. So to go to the route table, You're asking something, Mike?
Not at all. I was just I was looking at your video. It looked like it froze there for a second, but now it's better.
Yeah. I think
there's some reverb.
Yeah, it's like the frame rate we're not getting is a little slow.
Yeah, even it's slow here as well. Yeah, so you can see this is the route table. This is the default again. It's come with your account. If you see the routes, so there are two routes. One is the local routes, the implicit router will do, and the second is a default route to your gateway to the internet, and you need to have a internet gateway associated with it. If you click on it, so and that is attached. This internet, you need to attach the internet gateway to your VPC. So that is already attached.
And the internet gateway is just a router that connects to the internet.
Correct. So one thing I want to make sure we understand the concept is, if you have a public subnet, you need to have the gateway to go out. But if you have a private subnet, you can't go out. You need to create a NAT gateway. So that is the default setting. So let me go back. So the ingress router is it for the this is for the IPv6, and
Yes.
So your VPC and then subnet, and of course routing table and internet gateway. So these are the few key things you define when you create a custom VPC, and you advertise your route based on that. Any question, Mike?
No, I think you've done a really great explanation of showing that.
Yeah. So let me go to the next slide. Yeah. So we will be defining some subnets, the CIDR. CIDR stands for, of course, classless internet domain routing. Each VPC has a different block of address, and you can define /16. We will be defining the /16. If we go to the next slide. So again, as I described, a public subnet typically enable R2 assign public IP address, and the public subnet has a route to the internet gateway, and private subnet instance do not have any public IP. So we need to create an internet gateway or NAT gateway or any EC2 instance which act as a gateway, NAT gateway. So you can route this. So the public subnet will be look like this, and the private subnet will be look like this. But we need to create the internet gateway. There are some rules and guidelines. CIDR blocks are from AWS can be sized between /16 and /28. The CIDR blocks must not overlap with existing CIDR, and you cannot increase or decrease the size of existing CIDR. And the first 4 and last address are not available for use. And AWS recommend to use CIDR from RFC 1918, which is below here, 10, 10.00, 10, 172.16, 192.168. This. Anything you want to add here?
No. So these are these private addresses that we talked about, the ones that every organization uses that are specified in RFC 1918. As I mentioned previously, WAN links typically are /30s. LAN links typically make a /24 because that's typically what's a good subnet for LAN. Typically, you can go as big as a /23, but once you go above /23, you get too many broadcasts. Imran, do you want to talk about some general subnet guiding sizes otherwise? Because those are the two that I use. I use /30 for WAN links and /24s for LAN links.
Yeah, I think that's perfectly fine. Yeah, absolutely what you described. Yeah. My mouse is not moving for some reason. 1 second, Mike.
I know something about computers not doing what they're
So
supposed to. I had a Mac Pro forever.
Yeah,
Still
there's
miss my
some
Mac.
lag. Yeah, so there's some lagging. I don't know why. There's maybe internet or something.
There's some kind of lag that's coming from your house.
So yeah. So basically, we'll create these subnets. We create a VPC, and then we'll create this private subnets and public subnet, and the main CIDR you're using 10.0.0 or 16. We drive this from the other. You can use any calculator or SolarWind or anything. There are tons of calculators available. I just used it, and I drive this 6 subnets. We will put it in private subnet and public subnet. Then we'll create the route tables, and of course the main route table, internet gateway. Then of course the NACL, the NAT gateway for the public subnet, and route table. So let's create this. So go to your VPC. Like you can search from here. Like it's getting very slow, Mike. Sorry.
That's okay.
Yeah. There is a multiple ways you can browse, and you can see there's a one VPC. So if you launch, there are multiple ways you can create a VPC. If you launch a VPC wizard, they'll ask you VPC with public and private subnet, VPC with public and private subnet, hardware VPN, VPC with private subnet only on hardware access. So, but we will not do with this. We will just create a VPC with manually. Yeah, so that is getting very slow. I don't know.
Yeah, you're not on Wi-Fi, are you?
Yeah. I don't know. I'm on the Ethernet on this one.
I figured.
Yeah, that's Ethernet. Yeah. So there's something. So basically, we create a VPC, and we'll put a CIDR block, whatever we have.
I'm gonna lower my bit rate a little bit to see if that affects you.
So there's a question here in the chat box about the CIDR rules. Are they applicable to both public and private subnets?
Yes.
Okay. I figured that was a quick answer, so I just wanted to ask that one.
So I'm creating a VPC, and I was putting a like CIDR block, and I create a VPC. So that's a CIDR block I created. So now we'll add the subnets. We have it.
And as seen, these CIDR block rules are going to be on AWS, on Azure, on Cisco, and data centers. It doesn't matter. We're going to subnet and supernet the same way everywhere.
Yeah. I'm having a difficulty moving my mouse even though. So.
What's a demo without some technology? What's a demo without some technology challenges? Remember when Will Gates demoed Windows 98 and it crashed? I do. I was watching it. Did this just happen? I was demonstrating video on demand to the president of a phone company's house in his house, and out of nowhere, it worked all day. He shows up in the room, we're all excited, and then there's no IPTV.
So we'll create now. We'll create a subnet, and we will create the and that is the and the VPC we created. So we will choose this the VPC. You're seeing my screen clearly, Mike? So I'll put a name.
Working.
Yeah. So I'll just use this. This is like a public 1A. It doesn't matter. Is it a what address is? We are putting this in a public subnet, and what is the availability zone? So these are the availability zone. Means 4 data center. I choose the this is 1A. So I'll use 2A as a and I create the subnet. One second. So the VPC has been created. So I'll create the next subnet what I'll show to you. It's getting very slow, Mike.
I found the culprit. The culprit is on my end.
Your bandwidth?
My upload speed. Apparently, when nobody's in the office, I have no bandwidth. I don't get it.
I actually reduced my bit rate to try and see if that was going to help.
It did help. It did help, but I don't think it's compensating for the issue.
Let me lower my bit rate a little more.
But it's gotten better than it was a few minutes ago. So
yeah, it did, because I went from 7,500 megabit a second to 6,000. Let me go to 5 megs.
Yeah, it's moving. It's moving very, very well now on his.
Yeah, not everybody has the kind of internet bandwidth that I have. I went a little cuckoo on my internet. So
my upload speed just went up 15 times since I made that comment. So something on my end was happening. I don't know what it was.
I also dropped my bit rate, so we'll figure it out.
Yeah, because everything's coming through me on StreamYard, so that's why it's a combination of all the factors. Check the refrigerator; it might be running. Sorry.
Yeah, it wouldn't be too effective, you know. It used to be you could mine on the CPU, and then it became you could mine Bitcoin in a GPU, and then the hash rate of that was nothing. You had to use an FPGA, and then you could mine it on an ASIC. Hi, Cindy.
I don't know what's this. I can move it, Mike. You can hear me?
I can hear you. Actually, the whole thing disappeared off the screen.
Yeah.
You know, you said "Hey Cindy" right before that.
Yeah, so, no. My little baby girl walked into the room. She hasn't jumped on my lap. If she did, I'll pick her up in front of the camera. So
my screen is frozen. The laptop. I might need to reboot it. I don't know.
Well, if you need to reboot,
go ahead, do a reboot, and I'll talk about networking in the meantime. No matter what, we'll make it work. I'm always happy to talk about networking. That's all I know. I either know how to practice medicine or I know how to design networks. So love talking about networking.
Yeah, just if you need to reboot, just use that same link, and I'll get you set back up.
Okay.
All right.
We can do that, and you want to reboot, we'll ask their networking questions. It doesn't matter. We'll find a way, whatever we need to do to get our tech working.
Yeah. And it's not just tech where things don't work when they're supposed to. It's anything. Yeah, I used to work in hotels, and I was the opening day of a hotel. I had a grand opening with a lobby full.
But my video is going through, I believe, right?
Your video is good now.
Yeah, video is great.
So no bandwidth issue theoretically. Maybe with my PC or something. Yeah. Let's talk, Mike. Let me fix it while you're talking. So I don't want to reboot it. I will lost everything. So I don't want to remove it. My password
Yeah,
and
it totally
everything.
makes sense. So anyway, while Imram's cleaning up, who has questions about networking? I'm always happy to talk networking. We want to talk about IP, OSPF, intermediate systems, BGP, anything. Let's talk networking. Who has a networking question? As long as it's related to routing, we're in good shape.
So we had a question earlier from Ginny.
Okay.
Here we go.
Yes, we manually assign the private IPs.
All right. See, the questions get easier the later we go in the day.
Yeah, we really should.
Here we go. Here's another one.
Real question. Generally speaking, for LAN links, you should use a /24. And for a WAN links, you should use a /30. But for your VPC, you should use a /16, and that way you don't have to worry about running out of addresses later. Tech with Mufaz, what is the concept of CIDR? So Mufaz, you can go back to day one to actually go back and review this. Here's the thing, Tech with Mufaz. We used to have this concept of Class A, Class B, Class C, Class D, and Class E networks. And a Class A was basically something from 0 to 126, and it always had a /8 subnet mask. And basically speaking, we went from like 128 to 191, and that was a Class B address. And that was a /16. And the concept of a Class C was like 192 all the way to like 223. And basically, so we had a Class A, a Class B, a Class C. So when we're talking about those things, they were hard-coded with subnet masks. Then we realized that, we couldn't do this because we were going to run out of IP addresses, because every Ethernet port on your computer or every interface on a router needed to be on a different subnet. So if we put a Class A address, which had 16 million addresses on a single Ethernet port, we effectively lost all those 16 million addresses, Tech with Mufaz. So what we ultimately did instead is we decided to take a step back, and we decided to come up with this concept of classless interdomain routing. And to make classless interdomain routing work, what we did is we just would subnet. So instead of the /16, we would turn the /16 into 2 /17s. Or we would turn it into 4 /18s, or we would turn it into 8 /19s, or we would turn it into 16 /20s, or we would turn it into 32 /21s, or 64 /22s, or 128 /23s, or 256 /24s. So these are kind of one of those things that we're really talking about is, what we were actually doing. So just not adhering specifically to the periodic, what's the word I'm looking for? Not adhering to those classful boundaries of the Class A, Class B, Class C, those standard subnet masks that were originally defined. Otherwise, that's all we mean by CIDR. Who else has a question while we wait for Imran's PC to come back up? PCs do these things. Last time I did a solution architect presentation, my computer froze the entire time. Yeah, that's what you thought. Use a /24 as a standard for a subnet. /23 is the biggest you should ever go. Give yourself a /16 for the following reason. That gives you lots and lots and lots of address spaces. Like I showed you, a /16 will basically give you, how many did we count? A pretty good number of /24. So that's why I use a big block, because you never want to run out of IP addresses. You run out of IP addresses and it's a nightmare. So you definitely don't want to run out of IP. So your CIDR block is going to be big, and then you're going to chop it out. /30s for WAN links, because you only need two addresses on a WAN. /24 for LANs. And generally speaking, you are in really, really, really good shape.
And Mike, this is for me. Sorry, I have a question. So reading Mark's question here, the way that he's got this phrase. So all these /24, 23, 20, all the way to 17, they live, so they're inside the fold of /16, so to speak?
Yeah, because we're going to take that /16 and we're going to subnet it down.
Right.
So it has to be inside of it, yes.
Gotcha. I'm not a tech guy, so I just wanted to verify.
No, it's a great question.
Yeah.
You're a little more of a tech guy than you let on, but you'll mute me. So
I'm a coder. That's about all my tech.
Okay, fair point. Mario Medina, what is better and safe? Assign a dynamic IP or static? Generally speaking, servers, typically speaking, get assigned static IPs. And typically servers or things that you need static IPs, not only are static IPs, but in a traditional data center, you're going to hard code the speed and the duplex of the Ethernet port. So generally speaking, systems that need a specific long-term IP address, manually assign them. Use dynamic addresses for your PC. But a web server, you don't want that address changing. So use a static address.
So Mike, I'm having a hard time to connect to the Amazon console. We can chat and we can continue our demo maybe some other time. So I'm here
You
to
can't connect to the Amazon console?
No, something is wrong seriously here.
Okay, well, we got two options. You can probably any desk into my system, can remote control my system, and we can just share my
I'm having a hard time to getting this connected. So I think let's talk through the design thing and let's talk through, and we can the demo maybe some other time. So
well, where are we struggling?
no, I'm getting logged with my account on Amazon. So
okay, so let me answer another question or two, see what we can do, and if we can't get you into the account, the group has had a lot of design stuff during the day,
sure.
A lot of design stuff in the afternoon. So let's see what we can try and do. If you can't get to the internet, you can't get to the internet.
Yeah. No, I can get to the internet, but not Amazon console. And my account is locked for some reason. I don't know. I've tried 2 or 3 times. Yeah.
Oh, you want to just create another one?
Oh, that's required. I have 2 or 3 accounts already. So.
Oh,
I think let's talk. Do the demo. Maybe schedule another time. I don't know. And this computer is really slow. I rebooted.
okay, well, if you don't have access to the AWS console, I guess we can't demo it.
Yep. And computer is slow, and my account is locked. So I've tried a few passwords. So let's talk with the discussion, and maybe we can continue it another time. So.
Okay, well, we actually have class scheduled for tomorrow. So is there anything you wanted to address and teach while you were here?
No. What time you have class tomorrow?
12 to 3.
Eastern.
Eastern. Okay. Yeah. I'm busy till 4, but try to jump in on your class if you want to say anything specific.
All right. Well,
any other question we can address?
Yeah, if there's any questions, we can take some time to address some questions.
Any questions from anybody?
Mesh, I don't have an AWS account. Sorry, I do not play with AWS.
And my cloud's an OpenStack cloud, the one that I run.
Yeah.
No, I think
it also sits on all my servers, and that way I don't get any fees from any cloud providers.
I think we'll create another session, or maybe pre-recorded, and then create a live session again, Mike. So.
Okay, well,
yeah.
For everyone that was here, thank you for coming. I wish we could have deployed something a little better, but apparently Imran keeps getting kicked out of his account, and if we can't get in an account, not necessarily sure. One of the people has a free tier account. They're saying we can use it if we want to do it. Otherwise, we can just try and do it another time.
I think we.
I have multiple accounts, paid accounts, more than free accounts. So, and I manage some customer account as well. So I can log into that account. So.
I think, unfortunately, we'll just call it a day.
I think that's what we probably should do.
And there went his computer.
So,
Yeah.
computers are not infallible. So, anyway, I don't think we were able to do any kind of bonus class like we really wanted to do tonight. So, anyway, I will be teaching class tomorrow as usual. We will finish up the content and we'll make it a great experience. So, for those of you that were able to join, thank you. I really don't have any control to what's going on with Imram's internet access 1,500 miles away from me. I wish I did. If I did, I'd definitely go over there and fix it. But we definitely don't have the ability to do it from our geography. So everyone, have a wonderful night. Thank you so much. And maybe I'll actually get some rest.
Get a nap.
Yeah, I need to get a nap because, we've been running pretty hard here trying to make sure that we can give you guys a good experience. So we'll figure out the technology and make sure we show it to you another time.
Well, they can join us tomorrow morning at 9 o'clock Eastern and hear from some tech recruiters at ITSL.
I would, and they can tell you exactly how to get hired. So, we'll see you tomorrow. Ideally, come at 9:30. The tech recruiters, my favorite tech recruiters, are coming. It is going to be ITXL. I got to tell you, I've been working with them for 20 years. They've helped my people get hired for 20 years. They've helped me get 2 of the 5 jobs that I've ever gotten in my entire life. So let's go have fun. Let's enjoy ourselves. Get some good rest. And let's face it, a lot of that class is going to end tomorrow on some simple things. So if you guys desire, and we want to have a little bit more fun, let's be fair. Maybe we'll get a little bonus architecture work tomorrow. So 9 o'clock in the morning. Awesome. Ronald McRae received a LinkedIn inquiry from a recruiter. Excellent phone call this morning. And the first question was to tell me about yourself. Interestingly enough, I wonder where you practiced that, Ronald. And the next thing was you told them about your lab and they were really thrilled. So these are one of those kind of things. Bear with me. That's Imran. Hey, Imran.
Glad to hear that success story, Ronald.
It's a blue screen?
Awesome. Oh, God.
Okay. Anyway, I'm still on here. I'll call you back, Imran. But, I was wondering what happened. So I'll catch up to you real soon.
I thought the blue screen screen of death was gone.
Well, now we know why Imran's computer wasn't gone. So I think I may be the only person, and it really came from Chris's guidance, that when I actually deliver this, I actually have a spare computer that's literally up and running that's got special video encoder cards in it. And so my backup emergency computer has got an NVIDIA Quadro 5000 card in there just to make sure that when this dies, because every system will die, not only do I have 2 internet connections here, and do I have redundant firewalls in my house, I actually use redundant systems when we actually do this because, anything is possible. So have a wonderful night, everyone.
I got mine here.
Oh, that's your redundant backup too?
That's one of mine. You have a good question here from Mario if you have a few minutes.
Yeah, let's take it.
All right. There you go.
If you want to start your AWS architecture path, where should you start? So Mario, that is an extremely good question. So where do you have to start? The first thing you need to do is learn the network in the data center. And we're doing some good intro to networking this week. But you need to know a lot more on BGP, a lot more on routing, a lot more on switching, a lot more on QoS, a lot more on NAT, and a lot more on IP addressing. It's funny. Today, or was it yesterday, someone put a DevOps engineer says, hey, it's okay to use a subnet calculator. And my response was, no, it's not okay. And look, I don't care if anybody can use a subnet calculator. That doesn't really matter. The problem is the people that are actually doing the IP addressing should know IP addressing so well that it's in their head, that they automatically know where the subnets begin and end, because the IP addressing is the most complicated part. So first, there's that. So first, IP addressing, BGP, OSPF, intermediate systems, WAN links, direct connections, VPNs, IPsec. I covered them pretty heavily this week. NAT and all the use cases for NAT are really, really important. Then DNS, I covered that relatively heavily this week, so you're good there. Now, when it comes to the cloud, you've got to have a good understanding of virtualization. So actually, you know what? I'll give you a demo. You guys want a demo? I'll do a virtualization demo real quick. You want to know where to begin? Do you guys want a virtualization demo, or do you guys know virtualization? Because if you want a virtualization demo, I'll teach you what a virtual machine is, so you know forever what an EC2 instance is or a cloud VM. So, you know, oh, you're already going to the second interview round. That's great. So there's that. So what else do you need? What else do you need? And I'll do a virtualization demo so you guys can get it. But in addition to that, you need to know server virtualization, containers, firewalls, load balancers, IDS, IPS systems, and how to design these things. So those are the things you need to know. Now, Chris, you want to bring up back that question because so I can remember the name? The next thing to make sure, Mario, that you understand is an architect and an engineer are very different jobs. An engineer configures and builds. An architect designs and transforms. So when you're dealing with an architect, there is so much business acumen that you need to learn. So much so that you need to focus on developing the business, the communication skills, the leadership skills, the emotional intelligence, the executive presence. That is your skill set. That is 60% of your job. And for the people of mine, my students that get hired, I literally have to tell the engineers to not act like engineers, because the engineers want to go code. They want to go configure. They want to talk about the tech. And when you do that in an architect interview, you don't get hired, because then you become an engineer, not an architect. So the architect is all about the design. So as an architect, you need to do this. So let's take a pilot. A pilot doesn't train to be a flight attendant. The pilot needs to know how to fly the plane. The pilot needs to know how to deal with wind. The pilot needs to know with altitude, the vectors. That's what the pilot worries about. All too often where people go wrong is the architects try to train to be an engineer. They try to be the flight attendant. And they've got great flight attendant skills, but to fly a plane, you don't need to know what a flight attendant does. What the flight attendant does to you, the pilot, doesn't matter. What you need to do and I'm going to get to this virtualization demo in a minute, but I wanted to answer that question. But what you need to do as the pilot is related to flying the plane. So the biggest problem we have when people want to become architects is you train them to be an architect and they want to do engineering. So stay focused on architecture. So if you want to start your path, do the following. Learn the network, learn the data center. Get the minimum entry-level certification, which is the AWS Certified Solution Architect Professional. It has no relationship to the job, but it can and will increase your ability to get an interview. So we like that. Then focus on the business communication skills, the leadership skills, the emotional intelligence, executive presence, sales skills. Work on negotiation skills, deep negotiation skills, interview skills, and presentation skills. They are there. So I want you to focus on architecture to be an architect. If you focus on being an engineer and try and learn somebody else's job, you'll be really good at somebody else's job, but you won't be good at your job. And you know, a lot of times engineers want to say to me, if you don't know engineering, how can you do the job? Well, I practice medicine. I don't have to be a drug addict to take care of a drug addict. I don't have to have a heart attack to know how to take care of a patient with a heart attack. I have to know what to do and how to do it. I don't have to be a drug addict to take care of drug addicts. And I certainly don't have to have cardiovascular disease to be a cardiologist. And I don't need to have brain surgery in order to do brain surgery on somebody else. I need to know how to do it. So, Mario, that's where my best advice I can give you is focus on the right things. Train the job you want and you will get it. We have a cloud architect career development program and our people get hired. Half of what I have to do is keep people focused on architecture, because if they want to be engineers and they focus on engineering, then they run into problems. And when I've got my engineers on my program and they want to do engineering, I basically say to them, stop the engineering, and then they get hired. So it's a matter of training for the job. So let's do a virtualization demo. So I promised I would, but I wanted to ask that how to get hired question, because that question is a really important question. And I got to tell you, that's the question where I see 90% of the people go wrong. And when they go wrong, it keeps them from getting hired every day. So we architects know what we architects do, which is design. So train for the job you want, not somebody else's job. So let's do this. 192. Okay, so Chris, how do I share? What do? I share a screen. Then when I go to share a screen, I can share a, hold on.
Window.
Window?
Well, I'm assuming it's a window you need. Are you doing a VMware?
I am. Okay, can everybody see my VMware? Oh, good, you can. Okay, so here's what I'm going to do. I'm going to log into the system. This is virtualization at its best.
Could you zoom in a little bit? The little 3 ellipses in the top right corner, next to the M, like on the browser. Yeah, click that, and then okay, there we go.
Okay, so yeah, we can do this. So right now, every one of you can see my server. Now, every server at AWS, every server at Google, every server at Azure is a bare metal server that's got a hypervisor on it. A hypervisor is a type of software that basically sits between the physical hardware and the user. So what happens is the physical hardware will be chopped into logical hardware from the hypervisor. So let's look at our server here. We're on a brand new server here. Just installed VMware ESXi on this thing. I guess it was about a month ago. And the only reason I put any VMware on this is we were filming the Linux for Cloud Engineering program. When we were finishing the Linux for Cloud Engineer program, here's what we were doing. We were using another server. So look at the server. You can see this is one of my servers. You can see it's, oops, hold on. It would help if I actually go to the right browser window. You can see that it's a Dell 78 Precision 7810. It's technically a workstation. It's got two 12-core CPUs. They're Xeon E5 2690 V3s. You can see it's got 128 gigs of RAM. You can see the DNS servers. This 8.8.8.8 is Google's DNS server, and the 8.8.4.4 is Google's other Anycast server. You can see that its default gateway to get to the internet is over here, or at least to get off its network. You can see the BIOS version, and you can even see the serial number of my server. So now, let's go build some virtual machines. So the way this would work in virtualization, now if you're with AWS or Azure or Google, you just click from the drop-down menu, and it's done. Here, you're going to do it the hard way. It's not going to be pre-built. So first thing we're going to do is we're going to create and register a virtual machine. So we create one. And by the way, this is the way every enterprise works. And every virtual machine on the cloud, every EC2 instance, it's the same thing. So let's say we do this. Let's call this bad PC, because we'll be thinking about Imran's blue screen computer.
Now, Mike, we also just did an upload about this too, right?
We did, yes.
Okay.
And the reason I made an upload about this is so important. This is the fundamental for cloud computing. Without knowledge of this, there's nothing to know. And I will tell you that after interviewing 1,000 AWS certified people, less than 10 actually knew what VMware ESXi was, and less than 10 of them actually knew what a virtual machine was. The rest of the people thought an EC2 instance was an instance, but no one knew what it was. So that's why we're doing these things. That's why I made it.
I'm gonna put the link for that in the chat box for people to bookmark.
Excellent. So then basically we give it a compatibility version. Then we tell it the operating system we're going to use. Let's say we use Linux over here, and then we pick an operating system version. And that's going to kind of give it some guidance. So in this case, I think I have some Red Hat Enterprise Linux. I'm not exactly sure. I think I do. I think I have some CentOS. It's going to work either way, so I'm going to click it. Now the next thing I'm going to do is it's going to tell me my capacity that's left over and where I've got it. So basically speaking, I've got a 2 terabyte NVMe drive. This gives me about 500,000 IOPS and about 3,500 megabit per second throughput. I've got 1.7 terabytes free. So we'll click next. Now at this point, now we need to spec out the server. The server's got 24 physical cores. So guess what? We can add some. How many CPU cores? For the demo, we want it to be really fast and snappy. So I'm going to give it 8 cores. For the demo, we're going to make it really fast. So let's give it 16 gigs because I want this to be a fast demo. For the hard disk, let's give ourselves 50 gigs for what we're going to use. Then over here, what are we going to do? We're going to make sure we expose the hardware to the operating systems because we want it to be good. Then we have to specify a boot device. So let's see what kind of boot devices. Okay, great. We have CentOS 8, which is pretty much Red Hat Enterprise Linux, bit for bit copy of it. And we'll click next. We'll click finished. So now at this point, everyone, we just created a virtual machine, and it's going to be sitting here, and it's going to be called Bad PC. So the next thing we're going to do is we're going to turn it on. And now that we've turned this PC on, it's going to boot just like any regular computer. So let's install an operating system just like any other computer. We'll have some fun. Okay, the virtual computer is booting. It's loaded. It loaded the kernel. It's starting the Linux-based services to start the install, like any other server. Now, on the cloud, it's easy. You just click 3 buttons. But here, you're actually doing it the hard way. So by building your virtual machines this way and learning how to utilize your virtual machines, you're going to have something great. So in this case, we picked CentOS Stream 8, which is basically just Red Hat. And now we'll do this. We'll click continue. And then what do we have to do? We're going to tell it where we want it to be installed. In case you guys haven't done Linux, we're doing this for the network. Let's connect it. Let's turn it on so we don't have to enable the service later. Let's make sure, for whatever reason, I didn't click the disk. So let's make sure we click the disk properly. We need to set a root password. It needs to be an intelligent password. Do not use your cat's name. Do not use your dog's name. Do not use your birthday. Do not use your wife's birthday. And oh, by the way, do you know what the most common password on the internet was for many years? Cisco, CISCO, because it was a default password that shipped with routers, and we all had to put it in our CCIE exam. So for the most part, you could pretty much for a while, for about a decade, go to any router and type Cisco, and it was the password. Don't do that. It doesn't like my password because this is a machine that I'm going to literally delete inside of 2 minutes after we do it.
So Mike used Cindy at first.
I did with a string of about 10 numbers to make it less bad, but yes, I did use my cat's name because I'm going to delete this in 10 minutes. So the next thing that we need to do is we need to tell it what we're installing. Now, in this particular case, I didn't select any kind of build. I just let it go naturally, so we're going to be surprised. I think the Red Hat default is server with GUI. Now, the reality is you would never have a Linux server with a GUI because the GUI, or the graphical user interface, is another thing that uses resources, and it's a thing that can actually be hacked. So typically speaking, if you've got a server, you're going to be SSHing into that server and cleaning it up. But let's just install the operating system. So while we wait for the stuff to copy over, has everybody done this before? Are most people familiar with VMware ESXi? Because there's a Linux version of this that's free. It's called KVM. There's QEMU. These are the main hypervisors that are used. Citrix has some kind of a Zen hypervisor. I don't know anybody that uses Citrix in a long time, but they used to be out there for a while. So it looks like Genie's familiar, Certified Ethical's familiar. Good. I want you guys familiar with this because this stuff is pretty important stuff while we're installing. So there's lots of hypervisors that are out there. Now, this is a Type 1 hypervisor. Why is it a Type 1 hypervisor? Because it's installed directly on the bare metal. It's bare metal, it's VMware ESXi, and then it's just going to be the virtual machines we created. And we'll boot up this virtual machine in a minute as soon as it's done being installed. I'm just going to have to babble while it installs. So if you guys have any questions, now's the perfect time to ask some questions while we're doing this. But realistically speaking, all data centers, for the most part throughout the world, this is how they work. They're designed basically in this manner. They basically have a bunch of servers that all have hypervisors on them. Now, we've switched to this kind of virtualized environment about 15, 20 years ago. And the reason we did it is it made our data centers fast and efficient. So in many cases, many cases, what's going on is, the data centers, because they support virtualization, and because these data centers are actually supporting containers, and because these data centers are there, the data centers in themselves are really no different than a cloud. The only difference is who manages it. So data centers are getting very similar. So, that's what's realistically going on here. Now, instead of installing VMware ESXi, if we installed Nutanix on this, it would create a cloud. If we installed the OpenStack Ansible cloud, we'd be creating a cloud. We'd be building our own AWS. And I got to tell you, every student that I have in my Cloud Architect Career Development Program builds a cloud. I don't see how you can be a cloud architect unless you know what makes the cloud and how the cloud's built. Now, you're not going to be configuring things as an architect, but you still need to know about the cloud control plane, about the management and the orchestration of the cloud. You need to understand about the data plane or the forwarding plane of the cloud, which is the compute. You need to understand how the storage ties into it, the IAM, how it ties into the cloud. So these things become really, really, really important things. So when I hear these things, they become pretty important to me. So I just want to make sure that you guys get it. So we're almost done installing the server. No clue where they use servers come from. So I'll tell you where I got a lot of used servers. For a while, I think I was buying Amazon servers. Amazon Refurbished has good servers. Although I got to say, one of the best places I know to buy servers that are refurbished is the Server Store. They're in Texas. They've got a great product. They basically build your servers custom to order. So question from Solomon, it's not that a virtual machine makes it a cloud. What is a cloud? It's a network and a data center that's been virtualized. So if you walk into a data center and you've got servers, containers, load balancers, firewalls, VPN concentrators, block storage, object storage, file storage, that's the basis of a cloud. The only difference is that's physical. With cloud is you install the control plane on these same devices, and then it's virtualized and lower performance. But there's nothing different about a data center than the cloud. What do you do in the data center? You have your virtual machines, you've got your containers. What have you got on the cloud? Your virtual machines, your containers. Nothing's different. It's the same tech. It's just who'd your virtual machines come from? Is it VMware, your hypervisor, or is it the AWS Nitro hypervisor? It's the same. You install OpenStack in your data center, you install it on 500 servers. You can do auto scaling on your servers. You need 50 extra servers for the web server, scale them into the web server. You don't need 50 servers for the web server, scale them down. Those 50 servers can then be reallocated to an HR application. Dynamically, they can go up and down just like the cloud. So what makes the cloud any different is the fact that it's virtualized and managed by somebody else. The cloud is just somebody else's computer. That's it, just someone else's computer. Nothing's different at all. It's just somebody else is managing for it. So everything that you need to do is pretty much the same. So learn this, you know that. Learn that, and you will not know this, though. Why will that not equate to this? Because clicking 3 boxes on a management console to turn something on that's pre-built for you is not the same as building it yourself. Not the same as watching what happens to this physical server once the system goes on. And you'll be able to see the memory come out of the physical server. You'll be able to see the CPU resources taken by this virtual machine to the server. You'll understand what's under the hood at AWS. And when you understand what's under the hood, you're in a better position to design them. So just keep that in mind. Now, granted, you can see, these server installs are not necessarily the fastest. Now, mind you, this is a 24 server. And my definition is a virtual network in a data center because that's what a cloud is. It's a data center hosted somewhere else. They're virtual machines, they're containers, they're virtualized firewalls, they're virtualized storage, they're virtualized everything. Everything's just virtualized. It's no different than what you have in the data center. It's just virtualized. And because it's virtualized, when you ever use virtualization, you'll have a performance hit, which is why you can get about 7 million IOPS or 6 million IOPS on a hard drive in the data center. And the closest EBS volume you can get on the cloud is 250,000 IOPS because it's virtualized. It's just the same tech. Nothing's changed. It's just virtualized. So here I've got a virtual server. I also have an OpenStack cloud running here. Guess what? It's the same physical servers. They're the same servers. We installed the same Ubuntu operating system kernel, and then we install a control plane, which coincidentally installs MongoDB, which is a NoSQL database to manage all the accounts. We set up the block storage, just like you would anything else, which is where the servers store their information. When you set up an OpenStack cloud or an Nutanix cloud, you set up your virtualized load balancers, you set up your virtual firewalls. It's all the same. It's all the same. There is nothing special about a virtual machine, no matter where it's at. This is the same as an EC2 instance, which is the same like Compute Engine on Google, which is the same as an Azure virtual machine, which is the same as an Oracle virtual machine, which is the same as a virtual machine on the Palo Alto network. It's identical. Basically, server, hypervisor, operating system. It's the same. So the key is knowing what's the same and what's different. Where does the cloud get different? The orchestration of the cloud, because somebody manages the hard parts for you. They manage the physical infrastructure. They pre-build your images for you. It makes it faster. But realistically speaking, it's no different. It's just faster because these are the things. So hopefully our server will be finished being built in about 30 or 40 seconds and we'll be able to launch the server. We're getting pretty close because it's installing the Grub bootloader now. It copied the 1,351 files that are over. And then we'll be up. And then once this comes up, what we'll do is we'll literally walk through the server together. You'll be able to see where its DRAM is being used by the server. You'll be able to see how it's pulling resources from the physical server. And maybe we didn't do as much networking as I would like to do today, but you know what we can do? We can at least build a server. So regardless of what it is, if it's cloud networking, if it's cloud data center, you know, same thing. Our whole point and goal is to help you guys get cloud hired. So whatever we have to do that. So our system is in the process of getting close to being rebooted. Bear with us. We'll have built a server, and then we'll call it a night. We'll have built a server. You've seen how virtualization works. We did a little bit of VPC stuff, not as much as we would have wanted before Imran's PC blue screened. I think Imran will be reinstalling his operating system tonight. I know what that feels like. I do it more often than I would ever like. Perhaps that's what.
Imran sent me a text message saying I have lots of data. So that's his big concern right now. All that data.
Somehow I think not everybody has my backup strategy.
Yeah.
Backup local, backup to a cloud, backup to another remote location. So now whenever you do this, you got to accept the license. Yes, I agree, whatever. Okay, so now we've done this, and we've not created a user. So let's create a user, Cindy the cat. She's real cute, trust me. We'll give her a password. We'll call it Cindy the cat, which is a terrible password. But we're just going to log in, and then we're going to delete this. Cindy the cat. She's real cute. So then we're going to be done. Press done again. Oh, press done again to use the password. Oh, yeah, because it's not going to like the password. And then we'll finish the configuration. Here you go. Now we've taken a server. We've created a new server. We're going to log in as Cindy the cat. Cindy the cat's got magical powers. She can magically find squirrels, mice, frogs, bugs, lizards, and bring them all to me every single day. I don't know how she does it, but she's really good at it. Okay, so okay, there you go. Here's our server. It's completely up and running. So you got a server. Now, previously, I know earlier we were doing some things before. So for example, I was trying to show people to check for packet loss. So we can check our internet connection. We can do a ping, www.cisco.com. And we can look and we can see that we've got a relatively consistent internet connection. We can look at the path to get to cisco.com from my house. Would help if I could spell.
Security.
Okay, and there you can see the path for me to get there. Well, you can see the path until I get to their firewall. Once I get to the firewall, they're not going to let me see.
Now, Hans, Hans has a question. Can anyone access this VMware ESXi portal?
No, because it's sitting behind a firewall and it's got a private address. So like AWS, when you're there and basically you have a firewall, what I have in my house is very similar. I have a firewall, basically keeping people out. This isn't a private subnet, and I've got an access control list on the router that's actually doing the routing in my house. So first, you'd have to pass my firewall, then you'd have to pass my IDS IPS system, then you'd have to pass my network access list, and then I'm still behind a private subnet. So is it possible to hack? Sure, but this isn't really reachable for people, for normal people.
So this is your VMware ESXi.
This is my VMware personal server that's just sitting next to my main desktop that I use for experimentation purposes.
And then Ronald has a question about to pop up. Can you have more than one firewall?
Yes.
Yeah, there it is. Okay. All right. Mm-hmm.
And then I'll just shut itself off. But you know, that's what we're talking about when we're talking about these kind of virtualization and stuff. But I should have showed you guys. I should, well, let me just, is it still on? Did I shut it off or is it on? I think I shut it off. But realistically speaking, you could see the system, how much CPU performance it was taking. It's taking the memory. So now if you go to the host, it's been shut off. But what you'll see is more of the memory is being utilized. In fact, let me boot that up so you can see it. Linux-based system, that one's up. Test Linux. Let's power this system up. Let's power some servers up so you can see how the systems get greater utilization, so you get a feeling for it. And then let's this bad PC up. Let's power this up. Now let's go back to the server, and the server will be booted in a minute. Not sure what's going on over here. We don't need to. Okay, so that's up and running. Let me close this down just so you can see it. Now look at our server. Now notice with all these systems up and running, note that we're using about 5% of the memory, and note that we're now using, 3.9 gigahertz of the CPU being used by these other machines. So I've got 4 systems running on the system, and I still have 93% free capacity, or 94%. So that's why organizations are using the cloud. That's why organizations have been using virtualization, because these servers get so powerful, they can put a bunch of servers in a single environment. So, that's what we're kind of talking about over here. So prior to ending for the day, does anybody have any last questions for us? I think the question is related to physical security. How do you prevent people from getting access to the servers, Mario? It's a great question. It's going to be dependent upon how secure the environment is. So you're going to keep your servers, and AWS is going to do the same thing, in a data center. Now, the data center is going to be locked, and the data center is going to have security guards, and the data center is going to have cameras to make sure that nobody can get into the building. Now, when you're dealing with critical data, it's quite possible that you will have a lot of armed guards, and then you may have other invasive security methods as well, depending upon the value of the protection. You could have everything from a bunch of Marines standing guard to basically some simple basic armed security. But these systems are going to have to be locked, because if you get access to the servers, you can cause a massive amount of damage. So what we're talking about is some pretty serious stuff here. We're talking about some big challenges, and these are the kind of challenges that we're talking about. So lock the systems down, lock them in a building, make sure nobody can get access to them. And then if you use any kind of cameras, physical security guards, anything to keep everything locked down in tip-top shape and ultimately secure. So Mario, I hope I answered your question there.
And Mike has the best physical security. He has Cindy. So, yeah.
I do. I actually have extremely good physical security, but we'll talk about Cindy being part of the physical security, because my Cindy she's tough.
So I don't see any other questions yet.
Okay, well, tomorrow morning, Christina Mariano, ITXO.
Here we go. Yeah, finish your plug and we'll bring the question up.
So tomorrow morning, strongly recommend come visit ITXL. They always have something to say. Plus, they're the best recruiters I've ever met. I know a lot of really good recruiters, but pretty much it's so simple. I just have to call them and say, I've got someone solid, and they find them a job. So because of that, I think that it's really, you want to come up here, Cindy, and show up on camera? Can I borrow you for 1 second? Okay, Cindy, I know you don't like that. Okay, everybody, seriously, look at this baby girl. Look at this baby girl. I mean, just seriously. I mean, come on, everybody. Okay, Cindy, I know you really don't like that, but she likes to sit on my lap, but she doesn't like to be picked up. But I couldn't help it. All right, everybody. Cindy, thank you so much. So
I think we'll end on that note.
I think we'll end on Cindy the kitty. So everyone, have a wonderful night. I look forward to seeing you all tomorrow. Have a great night. Ronald, hi, Cindy. Yeah, the Cindy O cameo appearance changes everything. We love it. We love having her around. She's the mascot. She wrote an entire Go Cloud Architects book with us. She unplugs my servers every day. She's excellent at turning off servers with her paws, and she causes all kinds of things. Did you go to Imram's house and play with his computer when nobody was looking? I think that's what actually happened. So take care, everyone. Have a wonderful night. See you all tomorrow morning. And then tomorrow we'll have lots of fun.
All right. Bye-bye.